Okay, go ahead.
Hi everyone, I'm Stephen Capasso. I'm going to solve problem 2 from homework 3. I'm using this format with a painter's easel. Everything's pre-written already. It'll save me quite a bit of time because many times I go over the 5 minutes when I try to write everything out. Anyway, so this problem has to do with a uniform distribution over A to B. We're starting with a general case. Later we'll plug in actual numbers and see what happens. And we have y is equal to x squared. We need to find and draw f sub y sub y and the distribution function fx of x. There's an example in the book 5.2 which addresses this nicely. It's a quadratic problem. Y is equal to x squared, so x is equal to plus or minus the square root of y, and that distribution is shown here. Now, to get the actual thing that we want to plot, which is function of y sub y, which is going to look like this, we have to differentiate this with respect to y, and doing that we end up with this 1 over 2 square root of y over the whole x over x, and it now for this is general case. Now if x is even, you end up with a nice symmetrical shape like this. The other thing to note is if y is less than 0, it's always 0. So this is the case for y is greater than 0. You have this nice symmetrical even function. Right, so this is f sub y, function of y sub y. Next thing we want to find the distribution fx of x. And you start there by finding the function of x over a range. This is a and b. These are actual values for later, but it's something like this, shape-wise. And we need to put it in distribution form, which means we have to integrate that. If we integrate this uniform distribution, we're going to get a ramp, and it's going to rise up till we get to max amplitude of 1. I mean, that's basically the definition of the distribution function, is to reach 1. The next part, we put in some values, values for a and b, -1 and 3. As I'll show you this one more time on the right page. I had already updated f sub x over that range, and it's -1 to 3, and the amplitude is 1/4. And in the distribution function, there's a slope of 1/4, and that's how that came to be. Okay, so, all right, given that, we have to draw and find f sub y sub y and the distribution f sub x of y. I'm sorry, f sub y sub y. So this distribution, again, is going to accumulate and rise up to a value of 1. And the range is going to be from x squared, which is 9, the limit 3. We have 9, and at that point, we're up to our max level of 1. And then to find fy sub y, we have this expression here, and this equates to, this is described by 1 over 4 square root of y, which is this curve here. I really should have wrote that there. Let me do that. So this is 1 over 4 square root of y. That's this curve here. All right. And there are a couple of intercepts here. The max amplitude is 1/4, right? And that happens when y is equal to 1. That's about it. Okay.
Stop.
Yeah, stop.